All right, so we are back with Fredrick. Fredrick, I'm going to switch things up here to post the right one. There we go. So yeah, thanks for coming back in. I know that we had a little bit of a technical glitch there, so hopefully we can pick it right back up where you left off, and we can be on our way. So I'm going to add your screen in. I'm going to pop out and...
All right. Hi, everyone. A brief intro. I already introduced my name. I'm Fredrick, and today I'll be talking about GraphQL and e-commerce, building for the next billion users. A little bit about me. I'm a software engineer, technical writer at codisbay.com, and you can also find me online on Twitter and on GitHub at Future Developer. I'm also a web accessibility advocate and an open source lover. So today we'll be talking about GraphQL and GraphQL in e-commerce. Now, commercetools is a leader in the e-commerce space, and I wanted to use how we use GraphQL to give a bit of a practical feel of what it feels like to scale GraphQL, why we chose it, the challenges we had, and how we try to solve some of those. So commercetools is an API-driven e-commerce platform, which means that we are 100% API first. And that basically gives us the advantage of having digital touchpoints across all digital endpoint, all digital platforms, moving from wearables to IoT to web and various other platforms. Yeah, so to give a bit of history about GraphQL and how it relates to commercetools, GraphQL was created in 2012 at Facebook and used internally till 2015 when it was released to the public. And just a year after that, in 2016, it was adopted at commercetools and made public. And ever since then, it's basically been an upward climb. So by 2018, we had about 33% coverage at commercetools. And 2020, we had 81% of the core commerce APIs using GraphQL. And our goal is 100% coverage, and we are gradually getting there. I will also highlight that commercetools has the highest GraphQL coverage in the e-commerce industry, and we're gradually moving to 100% coverage. This graphic here shows the requests per million per day in millions of GraphQL at commercetools. As you can see, it gradually has moved to over 12 million requests per day and gradually keeps going up. Talking about GraphQL and how it relates to e-commerce, I would be using my virtual awesome shop here to give a more practical feel of that. Here I am fetching quite a couple of things on this page. I'm fetching the categories, I'm fetching the products, which basically includes the product name, an image, the prices, the size, and quite a number of resources. And I would be doing a bit of comparison, handling this using REST API and using GraphQL. With REST, we are basically going to be fetching all the resources available on this page and additional resources which we might not really need, which means that calling the endpoint to fetch categories, for instance, would fetch the category name and a lot of resources attached to categories. The same applies for prices or products. Using GraphQL, I can specify just the right amount of data I need. For this page, I'm specifying that for categories, I just need the category name, and GraphQL allows me to do just that. So basically with REST, I would be fetching the name and all other resources attached to the categories, which would be unnecessary in this case. But with GraphQL, I can specify that I just want the category name, and that's basically all I get. And this basically solves one problem, which is the issue of overfetching or underfetching. In this case, we are not overfetching, and we are certainly not underfetching because we are getting just the right amount of data. And it also has the advantage of giving us the opportunity to structure our resources based on the clients that would be consuming our API. Another reason why we chose GraphQL at commercetools and how it relates to e-commerce is for performance benefits. With GraphQL, you're getting reduced network usage, which means that invariably it consumes less resources for your users, and it is great when building for mobile clients. This benefit becomes really clear when handling resources for users that might be accessing our platform using low power devices like mobile phones, or using a capped data plan that might be on a 2G or a 3G, or for users that might be accessing our platform or our resources on a low-end device in a remote location. This means that we are not basically forcing down a bunch of unnecessary data down their throat, and that means they're suffering from increased usage of their data, battery drain, excessive network usage. All those are taken care of and become an issue of a thing of the past, basically, with GraphQL. So we're getting advantage of increased performance and this bunch of other benefits attached to it. Another reason why we chose GraphQL is speed. So with GraphQL, we're getting huge speed gains for low-end devices and wearables like the watch or other similar devices. And we're basically saying goodbye to unnecessary payloads. Also, it means an improved overall user experience. So the user has more confidence using our resources or accessing our platform, because they get the performance gains. In addition to that, they also get the speed gains as well. So I would be doing a quick demo. It will be a video that shows the benefits we got speed-wise when we moved our mobile to GraphQL from REST. So I would illustrate that using this video. So a bit of what's happening here. By the left-hand side, we are fetching a product on the Apple Watch 2, and that is using GraphQL REST API, while on the right, we're fetching the same resource, but using GraphQL. So this basically happens on a device that is, we're using a device that is not the most recent, which means it's a bit outdated, and goes to show the actual gains that GraphQL offers us in this case. So let me play the video. Okay, I will play that just one more time. So by the left, we're fetching using REST, and by the right, we're fetching using GraphQL. You can see the speed differences here. Moving on. So how does GraphQL make this possible? ties to basically the native functionality or benefits that GraphQL offers, which is that it allows you to ask for what you need and get exactly that. So in this scenario, we're specifying that we are creating a type called products, and it would have 4 fields. This is very simplified example. In this case, we have an ID, we have a key, we have version, and we have SKUs. And we specify the types for each of these fields. When we request for data, we specify that we just want the ID, the key, and the SKUs. And despite having the availability of the version, we are not requesting for that because we don't need it. And the response is basically intuitive. So it gets us exactly what we need, what we ask for, and it basically mirrors our response. So GraphQL at scale, how does this happen? Is this really a thing? Can GraphQL scale? Does it scale? So I will be showing a couple of users of GraphQL that are already doing over 1 billion requests using GraphQL. One will be Contentful. Contentful is making over 1 billion GraphQL requests per month. They released this statement last month, August, showing that they have crossed the 1 billion GraphQL requests served per month milestone, which is really, really awesome. And another would be Facebook. So Facebook is basically where GraphQL started, and you can see the mind-blowing figures there. Now, as of 2015, Nick Schrock, one of the co-creators of GraphQL, stated that Facebook was making over 260 billion requests per day using GraphQL. That is simply mind-blowing. 260 billion requests per day, and this was in 2015. So doing a quick projection of that between 2015 to 2016 would be even more massive than now. Now, obviously, there are challenges that would come with building at scale using GraphQL, and we would take a look at some of those. One would be complex queries. Now, performance issues can arise for deeply nested queries. How does this happen? I would be showing a quick request. So as you can see in this request for the categories here, we're making quite a deeply nested. It's basically really deeply nested, and can keep going on and on and on and on. Now, this would be considered a bit malicious, because for what reason would a user be making such a request? But it's basically this shows you that this is a possibility and this can happen, because you can have really deeply nested queries that can take a performance hit on your server. Another would be database operations. So with GraphQL, you can actually have a single query that potentially generates a lot of database calls. Now, this can have quite a negative effect on your database, because it can really take a negative impact on it. But this is a possibility, and it is a challenge that comes with GraphQL. So I will be talking about how we solved some of these challenges and how you can also incorporate this into your tech stack or tools. To enable some of these solutions, we have Sangria, which is a Scala GraphQL implementation. Now, this library was actually created in-house by one of our engineers at commercetools, and it offers you some advantage, some benefits that you can key into to handle some of the challenges that we took a look at. How we solved some of them. Now, the first would be amount limiting, which basically means that we are setting a default limit for our queries. So if a user is making a request for has a query that has a limit that is above 500, we basically error that out. Now, you might be wondering, does that mean that the user cannot get a resource that is above 500? Yes, the user can definitely get that. And to enable that, we have pagination for the resources. So you could set a different offset for the next bunch of resources that you're getting. And the next solution we have is basically an optimization, which means that to fetch a specific resource without any limits attached, we have a default limit given, which is each resource has a default of 20, which means that without specifying a limit, we only return just 20 results. I would also be showing that shortly in a quick demo. Another way we solve this would be pre-computed queries. So GraphQL is already typed and has validation attached, which means that the clients can take advantage of that to ensure that before the query even gets to the backend where it is handled, there is proper validation handled. So, which means that anything that is going from the clients to the backend is already validated beforehand, and basically that reduces the issues that might be related to the query failing or not returning the expected results. Another way we solved the challenges we experienced with GraphQL is having a cost calculator. So basically, this means that we're able to calculate how expensive a request is, and even if it's not performance, it's rejected. Now we have a complexity limit of 20,000, and if a request is computed and it is above this limit, it's considered non-performant and rejected. Also, what enables us to take advantage of this is the Sangria library, which I mentioned earlier, which has which offers default complexities, but this can be customized on a per field level. And if you would want to look at how this can be handled or to take advantage of this further, I would also have resources attached at the end of the slides where you can take a further look at how we implemented this using one of our technical blog posts. Now, this is a visual representation of making a request that goes beyond the query complexity we have. So in this case, I am making a request for categories, and it's quite deeply nested, and we have a limit of 500. Now, if the limit here goes beyond, if the complexity computed for this query goes beyond 20,000, it basically errors out and returns the error message, which specifies what happened and a computation of the actual complexity number. So with this, which is available using the graphical interface, where you can actually see this, or using some other API clients, I would also show that using Insomnia, you would get a basically a first-hand look at how performant your query is so that you could optimize it much further. Now, how do we analyze the cost of these queries, which I talked about? Ta-da! So this is not really magical. It's handled in the next slide, which I will be sharing here. So first, we have a field which is called the GraphQL query complexity, which is available in the response header. And this shows you the complexity of a query that you're making. And attached to it is the value. So if the value is below 20,000, then it's totally fine. The query will get resolved and the response will be returned. I will be showing this quickly using an API client. So I would stop sharing my slides and share my entire screen. Just a moment. Okay. So here I have Insomnia already set up, and I would be making a query that is basically going to fail because it exceeds the complexity of 20,000. And the idea of this is to show us how can we know what is happening. So our query is failing. Why is it failing? What's happening? So I already have this written out, so I would not spend a lot of time on it. So I can specify that this has a limit of 5,000, which is obviously not going to be accepted. Say the user was not aware of such a limit and tries to make a request like this. So I make the request and I get a 400. So the message says the query is too complex or expensive. And right here we have the complexity number, which is about over 62,000. So I can also take a look at the header here. Okay. So just a moment. Let me, yeah. Okay, so I would specify the same here. Yeah. Okay. I would need to double check on this. But basically the client returns the specified the client returns the X GraphQL query complexity header in the response, which is basically similar to the error that we saw, where we see the actual computed value of the response that the user got for the complexity of that query. Another way of seeing this, if the user does not have such an API client and might want to use the graphical interface, they also get a similar response. So I would just share this for graphical. Just a moment. Okay. Why not this? Just a moment. Okay, so this is a graphical interface where we're making the same requests. We're setting the same limits of, say, any number above 20. Let me just, any number above 500, basically. So this also gives us the same response, which is similar to what we saw using the Insomnia API client. And it has a computation of the query complexity, which basically means that the query is beyond the allowed complexity number here, which is 20,000. And the user can optimize this better and get just the amount of data they need. Or if the limit is updated, so say I might just have no limits here, so we just get the defaults. So I make the same requests. Yes, so in this case, we have no limits attached, so we default to 20 results for the user. And if the user would want to get even more results than 500, which is the limit, then they can add an offset to get that as well. I will quickly go back to my slides. So we've talked about the GraphQL query complexity header, and we've also taken a look at how we can handle this using the graphical interface. And that's basically it. So for additional resources on how to implement this, we have a good resource here attached, which is the implementation for graphical using for GraphQL using Sangria. And this is a blog post that really goes into detail on how this can be implemented. And for some other resources on how to additionally handle some of the challenges that you might have with implementing GraphQL at scale, we have a blog post here by Apollo GraphQL, and also a resource by GitHub and our technical blog, which goes into detail on how we handled some of these challenges. Thank you.
All right, there we go. So, Fredrick, thank you so much for doing that talk, and thanks for joining back in. I know we had a couple technical issues, but we solved them. So, thanks for being flexible there. Yeah, thanks for doing this talk today. And that about wraps it up. We'd like to thank all of our speakers today. So, thank you again, Fredrick. Thank you, William. Thank you, Daniel. Appreciate everyone being here. Joining in this GraphQL Berlin / Munich meetup. So a couple of reminders, check out commercetools. This meetup is done in conjunction with commercetools and GraphQL Munich. So check those places out. And we will get information about the next GraphQL Berlin meetup out to folks as soon as we have it finalized. And until then, we will catch everyone later.